Hello everyone, welcome to Learning Activity 13. We are in the final week of Introduction to Machine Learning. This will wrap up our course this week with all learning activities. So Learning Activity 13, 14, 15, and our sync session 16 will be the final for the Applied Data Science and Machine Learning certificate. So we're almost there. We got a few more things to knock out, but some housekeeping items that we have to do for this week is I do want to just impress upon you, make sure, if you can, make sure you get to the final in person, please, if you can. Get to the final sync session. We've got a lot of stuff to cover, as well as activities to kind of close out activities to make sure that we've got that taken care of for you, of course. So anyway, here's what we need you to do right now is I need you to go out to GitHub, go out to the remote repo, and I'm going to go ahead and give you it's all updated for our latest content out on the student remote GitHub repo. And learning activities 13, 14, 15, and 16 have been put up there. This week is slightly different. The reason that I want to preface some of our final week's activities is because we have quite a bit that we have to. There's some things that are slightly different. So go ahead and get GitHub, your GitHub desktop, and then go ahead and go to your repository, your KSUS IML main, do a pull to get a refresh, and you should be good to go. Okay, now once you've done that, one of the things that I do want to preface everyone with is that Learning Activity 13, the one we're working on, we've got our async material, but you'll notice that there's no sync notebook this week. That will be the case also for Learning Activity 14. There is no sync session materials for that one. The sync session actually starts off for this week in Learning Activity 15. We'll do a sync session. So there's 3 sync sessions for this week, or rather there's 1 sync session with 3 different materials, so 3 different topics. The first is we've got a model metrics session that we'll kick our week off with, and this one's going to be a little bit more complicated, so we'll do this as a group effort, and so that's one that we'll tackle here. But in our sync session, I've changed it up a little bit. We've got a PowerPoint. This is actually a machine learning template PowerPoint for you to use for within your organization or whatever you want. It's just meant to structure and help kind of guide the conversation. If you ever do use this materials to print, you've got a PowerPoint to help print this, to help kind of structure the conversation at a C-suite level. There's some things that you might use depending on if you have a more technically oriented C-suite versus a more business oriented C-suite. It just kind of we'll give you a little bit that can handle both. But it's definitely high level. Hopefully that will give you some nice tools that you can take away from the course. The drill sessions for this week, we're going to have the other 2. So I mentioned there's 3 activities within our sync session this week. And that's going to be, we have 16A and 16B. And 16A is setting some time aside to help actually structure that PowerPoint. So we're going to take everything that we learned from the course up to this point, and then we're going to, in the second session of our second activity within the sync session this week, we're going to focus on building out the first half of this PowerPoint. And then in the last session for our sync session, the very final one, we'll build out the second half. And then once we do that, we'll take 10 minutes to debrief as a team, as a group, and then just kind of get a litmus test of how do you feel about the overall plan, the overall vision, and it's meant to be fast. Of course, you can beautify it afterwards, but it's meant to just get the content, get it in, and get it out so that you've got a feel for how to do this on at the enterprise level. Okay, so that's the initial prep work. Let's go ahead and jump over to our PowerPoint for this week, which is Learning Activity 13, Model Evaluation. So we're going to go ahead and jump into this this week's activities. So up for lecture, we've got machine learning architecture. We'll talk about the difference between outside the database versus inside the database. SQL Server machine learning services, prepping the server from ML operations. We've got new technology that we have to talk through. And so what just kind of a game plan for what this is a game plan. So this is probably one of the more, this one and last week are probably the most complicated lecture and lab that we've got for this week. There's just no getting around what we had to do. But after this, it kind of eases up. So after learning activity 13, we get through some of the dense parts here. We get to learning activity 14 and 15, it eases up. So, okay, on the lab side, we've got to install, I mentioned new technology, we got to install a new SQL Server machine learning service. We didn't need it up to this point, mainly because I just didn't want to complicate things, but that's why I say that we've got a few moving parts here in this lab. So we've got one more thing we've got to install. I promise it's not terrible. It's not too hard, but it does get into when on the lab side, the machine learning integration, the machine learning model storage, the machine learning model evaluation. So there's a lot of things in there that have to be unpacked, and so we're going to be spending a lot of time doing the hard stuff, which is what we call the final mile work. So we're actually in this learning activity. We're going to be laying the foundation for operationalizing our machine learning models. So this is where we make a big giant distinction between what data science work is and what machine learning work is. So data science work doesn't focus on the operationalization of statistical models. So that's something that we're bridging the gap here with this course, is teaching you how to take that final mile, and that's why this is the hard part. That's why the tail end of last week and the front end of this week, it's the hard stuff. We're getting into the nitty gritty. So let's go ahead and get through this lecture, then we'll jump into the lab. So the differences between what we did before is we've got the machine learning, this outside of the database architecture. We've already done this for TSNE and PCA. In PCA, we actually can do this for our linear regression, and we're actually not going to do that because I want to show you a way where you can certainly operationalize outside the database, but using a machine learning service, there's plenty of them. You don't have to use Microsoft's. There's other machine learning services that exist out there too. But it's one that works well for what we're trying to do, and seamlessly, I might add. So it's a really nice integration. Even at the code level, it works really well. Okay, so we've got our AdventureWorks database, and ODBC data frame features. We did a dimensionality reduction. We did a fit on TSNE. We did a standardize and fit in principal component analysis. And that is an outside the database architecture. What I mean by that is everything that you see outside of the AW can, that was outside the database, and we connected to AW or AdventureWorks through an ODBC API. So we use, remember, PyODBC, and we had to use a connection string. We had to use like a lot of stuff there. We had to pass a SQL script. We had to do some cursor and then pass that over to a data frame. And that's all considered outside the database. That's an outside of the database machine learning architecture. Again, sometimes you can't get away from that. One's not better than the other. It's just there's pros and cons to each, of course. Sometimes you have to do an ML architecture outside of the database just because based on the architecture you're using, or proximity to the database itself. Next up, we have what's called a machine learning architecture that's from inside the database. So here, this is just kind of another slicked up version. I pulled this from Microsoft's website because it's kind of got a nice view to it. But you can see there's a lot more going on the left side. So this is the machine learning outside. On the right side, it's machine learning in the database. And basically, because the model, we're actually storing the model physically. There's a couple things we have to do to store the regression model itself. Remember, is a separate artifact, a separate object that we have to create in code, and we actually can save that off as a binary and save it within the database that we can refer to later, and we can just call within the database like real time. So that's really what's kind of nice here is this actually gives us an ability to greatly reduce the footprint, how much stuff is happening, how many moving parts. But it requires us to go back in and brush up on SQL and learn a couple new technologies. Again, going at it from the outside of the database is not a bad way to go. It's just it just depends on what it is you're trying to go for. So in this case, an in the database machine learning strategy is really good for us in what we're trying to accomplish. It makes a lot of sense. So that's what I'm gonna teach you how to do and how to operationalize it in this way. Okay, so what do we need? We need to have SQL Server Machine Learning Service. Well, SQL Server Machine Learning Service is great for both Python and R. So operationalizing R, we're not using R, but again, it's a great language. I love using it. I like Python because it's just more accessible, and I have a lot more capabilities and fingers into a lot of other frameworks because Python gives me that ability to do a lot of different things, whereas R doesn't quite have that portability that Python does in that regard. So we're using Python, but the good news is that SQL Server Machine Learning Service runs Python and R out of the box. We don't have to do anything special. Actually, it'll run Java also, but I'm just not a big fan of using Java for machine learning purposes. A lot of it is just if I'm going to do machine learning, Python's just the best way to go. From an operationalization perspective. If you're going to do pure data science, R is great for that. If you're going to just do a data science play, I also like R for prototyping models, but again, it's a heavy lift if people aren't in the kind of the CS world. You only have so much time and so much time to spend towards your sensitizing your teams rather to a specific architecture. So from in my experience, you don't want to get too fractured because it becomes costly from a human capital perspective, because you don't want people coming in with two different language sets, and just pick one and go with one. And in this case, you kind of can't go wrong because R also operationalizes well within SQL Server. So okay, let's move on to the next thing. So we got to do a couple things. We got this new software we're going to install to augment our SQL Server. We also have to reconfigure the SQL Server. I promise this sounds like a lot of stuff, but it's really not terrible. I will walk you through every piece of it. You're going to feel like a hacker when you're done here, because we're really getting into some of the really old parts of SQL Server that few people actually don't see that much anymore, that actually still available for you to poke at. Back in the old days when we used to do database administration, all of these config parameters you had to tell. SQL Server just wasn't that smart. You had to tell how many CPUs it had. You had to tell it how much memory it had available to it. It didn't grow according to what it was in, so it didn't learn. It wasn't that smart. So in the old days, we used to spend a lot of time configuring SQL Server, all the way down to a certain extent down at a hardware level to get these things configured. Now we don't have to do hardly any of that anymore. It's they've really built in a lot of intelligence into the engine itself. So when you install it, it knows what it's getting installed into, and reconfigures itself and aligns it to what it needs to run optimally. However, there are some little services that need to be, in this case, we have a new one called Machine Learning Service, and we do have to configure it. We have to jump in and do a little bit of surgical precision in the internal guts of SQL Server to make an adjustment to allow this thing to run external scripts. So we'll do that, and the next thing is there's two new concepts I'm introducing to you, which is stored procedures, or SPROCs. They're very similar kind of to views. If you're familiar with views, stored procedures have kind of a similar flavor, in that if I take a block of code and I can compile it down into a view, that's kind of the same concept here. But stored procedures are more programmatic. They can produce data as an output, but stored procedures are built for taking arguments in and pushing arguments out. So they very much act like Python functions. It's probably that's probably the easiest way to think of what store procedures are. But they're stored SQL procedures, and we call them sprocs for short, or just if it's a sproc. That's typically that's the lingo we would use when we're talking about store procedures. So just know that they are we're going to be using these in this case to take Python. We'll take Python code, and it's going to be a mixed environment where in what we've been working up to this point is Python sprinkled with a little SQL. But now in this set of activities, it's going to be a lot of SQL, maybe about 50-50. There'll be SQL 50% and Python 50% because we're going to be embedding Python code within SQL to be executed. So programmatically, the store procedures control the execution, as well as the landing areas, as well as the model and the storage of the model. That's all going to be managed by SQL. Okay, so next up is pickle. So Python, I've got to introduce you to the pickle process because this actually is used quite a bit. And this is something that we would use, we actually use quite a bit. But it's called pickling and unpickling. But Python, and it's literally called the pickle library. It's import pickle, and we're going to be using that. So if I've got, and just understand that essentially a pickle process is when I implement the pickle Python library, it's a way of flattening data. So they call it serialization, or I can serialize the data. That's just a fancy word for um, flattening the data. And in this case, they call it pickle and unpickle. Pickle is the process of flattening the data, and on the left, this is what it does. It essentially takes it rotates the data into flat form. That's probably the easiest way to visualize it. But there's more that goes into it. I just kind of want you to just see that visual for right now. But in the back end, on the right hand side, that's kind of more what's happening. We take this data and we convert it to zeros and ones. It's actually, and then we save it as a hex, a hex, a byte array that we can actually, byte array is probably a byte, probably a binary object. Let's say it that way. We save it as a binary object. That's the best way to explain it. And we flatten it out. And then that allows us to, in this case, we want to flatten it out and save it as a binary file, or rather a binary object, so that we can save it and store it in a table. We're actually going to take a binary object and save it in a table, which is kind of cool because then we can retrieve that later on down the road for whatever it is we want to do. But that's we're going to pickle our model and put it into the database that way. And then there is a process of unpickling it, or deserializing the data and then bringing it back for usage. So that's just one of the things that one of the two extra things so that we're going to be installing, well, three rather. So we've got the machine learning service, and then we've got the machine learning service we're going to install. We've got the store procedure that we're going to create multiple store procedures, and then we're going to pickle. We're going to use the pickle process to help us along with that process. Okay, so high level. So now that we talked all the technology, let's talk about what we're doing today. So everyone here is familiar with the product, the AdventureWorks database up to this point. You know that we've got a lot of data to work with, a fair amount, not tons, but a fair amount of data to work with. And so what we're going to do today is we're going to revisit back to a predictive model. We did ordinary least squares, and we did a simple linear regression the last time we did that. And in that case, we just did we did a couple examples. We did a prediction for OLS using a simple linear regression technique on one X and one Y. And that was the temperature to ice cream sales example. And then we predicted the ice cream sales based on what the outside temperature looks like. But we also talked about what else might happen, right? In other words, what other data should we also take into account like seasonality, what time of the year, what time of the week, what time of the day? These are all types of things that would absolutely give us a better prediction of when to expect sales, ice cream sales, right? Because if it's Saturday afternoon on a June day, right? June Saturday afternoon, we're gonna expect to see some higher sales versus if it was Saturday on a December, right? And location also matters too, right? Because if I'm in Key West, I might be able to have consistent Saturday sales throughout. It just depends on, I might have some seasonality as it relates to the tourist season. So that's another thing that we'd have. But where I'm going is that rarely do you use simple linear regression because it's just too simple. So what we're going to do is multiple linear regression. And so, yes, we are going to be. So the linear regression function can handle multiple incoming IVs, and that makes it a multiple linear regression. And so what we're going to do is we're going to take the production.product data, which we found based on our correlation matrices that we run, right? We did that iteration and found that there's quite a bit going on in the production.product table. I mean, that we saw quite a few things that show some promise, right? That so in other words, it let us know that we were going down the right track. So we're going to take product IDs, make flag, finished good flag, safety product, safety stock level rather, standard cost, list price, and weight, and then we're going to use those. We're gonna use all those to create a. Those are going to be our predictors that we use to have a predicted observational variable, which is in this case days to manufacture. So we're going to use everything over here to predict days to manufacture. So yes, we are going to do a multiple linear regression. So we're getting into the big enterprise level. We're getting into the big leagues in terms of the way that we're starting to approach this. Okay, so this is just some add-on information, FYI for you. So there are 4 levels. There's actually quite a few more, and I'll talk about those off page here. But I have simple linear regression, which we've done, right? Which was the OLS for ice cream. And then there is the multiple linear regression, which we are going to operationalize. And that's where we have more than 2. We have 2 or more IVs to 1 DV, and that's a multiple linear regression. Multivariate linear regression is where I have 1 IV to more than two or more dependent variables. And then there's actually multivariate multiple linear regression, so that's quite a mouthful there. That's where it's multiple IVs and multiple DVs. Now, there's actually a lot of different ways you can handle this. There's many different algorithms that can handle things in different ways. You actually have logistic regression. You have multinomial regression. Those are others that handle categorical data where it's not continuous. So in the logistic regression world, that's a binary bit, either on or off. So you're evaluating yes and no. And then in the case of multinomial logistic regression, you have categorical variables where it's not just 0 and 1 as the categorical variables. So some things to keep in mind when we talk about DVs, you'll hear that called sometimes the outcome variable or the response or the observed variable. It just depends on the situation, and it also depends on the person that's modeling it. Sometimes statisticians or a scientist or they all have different ways of kind of looking at this, but they're all kind of describing the same thing. On the flip side, IVs will sometimes be called predictor or explanatory variables. So, but anyway, we're definitely moving up a step because simple linear is really just so basic we can't really use it for just we can use it for educational purposes, but we really can't use it beyond anything because it just can't handle anything beyond that, beyond just the one IV, 1 DV model. It's just not good. But anything past that's fair game. Like a multiple, using multiple linear or multivariate linear, or multivariate multiple linear. Those are all like starting to get into the industrial grade area of linear regression. Still very useful, but you have to be able to process multiple incoming IVs to get to a DV, so or a predicted output. Okay, so I think I've talked enough about this part. I think what we need to do is we need to go do the lab. So let's go ahead and jump over, finish this lecture up, and let's work on this lab.